So taking a look at page 143 and 144, looking at problems 1 through 5. Is there anything on 1 through 5 you'd like to see? Yeah. 3, you got it. Number 3. We have x minus y squared. So you have 2x minus y's, like this, which means this is going to be x squared minus xy plus y squared. That's just multiplying here, 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 and here, here. So that's going to be x squared minus 2xy plus y squared. So that's a perfect squared trinomial in this case. Okay? Anything else up through number 5 you want to see? Yeah?
Number 5.
You got it. Number 5, we have this. We have a negative, and you have x minus 1 quantity squared plus 11. Okay, so this negative is going to come down, and this plus 11 are going to come down. I'm still going to have some stuff in parentheses, but I have to realize this. This is the same thing as x minus 1, x minus 1. If I multiply that together, I'm going to get x squared minus 1x plus 1. Yeah, baby. I'll get that graded in the book. And then this negative still come down, bless you. This is x squared minus 2x plus 1 plus 11. Distribute this negative here, here, and here. And then combine your two last terms. That's it. Anything else on page 1 up to number 14? Anything up to number? Yeah, Brian. 11. 11 is a little goofy. I don't know if I'd actually have one like this for you, but let's just take a look at it anyhow. So I would move the 36y squared over, give me this. And then it becomes equal to 0, which is goofy because I'm trying to solve for 0 when I have two variables. Sometimes math is goofy, but hey. All right, so this is going to be the difference of two squares because 25x squared is the same thing as 5x times 5x. 36y squared is the same thing as 6y times 6y. So I'm going to get 5x plus 6y, 5x minus 6y. I'd probably just leave it like that. You don't have to take it much further. Yeah. 13. Yeah. Number 13 will be right here. All right, number 13. Let's see. It doesn't look like I have a greatest common factor. So things that I would probably recognize is that I know that that's the same thing as 4x times 4x. It's also the same thing as 2 and 8. But my front and my back end numbers happen to both be perfect squares. So I think this problem is going to be 4x plus 3, 4x plus 3. Now let's just double check to make sure we did this right. We might have a sign to change it or something, but say 4x times 4x is 16x squared. 4x times 3 is 12x. 4x times 3 is 12x. 12x and 12x is positive 24. Oh, I need to make, this has to be a minus right here. And this has to be a minus here. So you have to have those both be in minuses. And then if my last term is negative 3 times negative 3 is positive 9. So now I could set this equal to 0. You only have to solve one of them because you have the same thing repeating. So this is a perfect square trinomial. Divide by. Get there. Anything else on that front page you want to take a look at?
14.
Okay. 14. Got, let's do this. We'll split the screen. number 14. Let's see. I got 16 minus equals 25 y squared. Let's bring the 16 over. This is now the difference of two squares. So I'm going to get 5y plus 4 and 5y minus 4. Doesn't matter that the equal sign's over on this side. It's still going to work out the same. So then I got 5y plus 4 equals 0. 5y minus 4 equals 0. So I get 5y equals negative 4. So y equals negative 4 over 5. 5y equals 4. So y equals. So I get an answer of positive 5 over 4 and an answer of negative 4 over 5. 4 over. Same things backwards. Yeah.
So you just find the square roots of like 25 and in
16.
11 it was 36 and 45.
Right. That's a perfect square. That's a perfect square separated by subtraction. So it's got to be the difference of two squares. All right. Flip of the page. I'm not worried about 24 and 25. Actually, there's not too many I'm worried about on this back side. Yeah. Okay, you're here. You did it. Cool. Good for you. If you weren't here, then you have to do it. And turn it in, please. Let me get some notes out, y'all. These are all mine. Okay, so we are going to start solving quadratic equations. So far we've been able to do it where they factor, difference of two squares factors, but there's other things that we have to remember with that we have to worry about these. So let's say we have square root of 125, okay? Yes, I understand your calculator will give you 11 point something that goes on forever. I get it. But I want an exact answer. We're going to talk a little bit more about exact answers here in a few minutes. But what I'm going to do when I do this is I'm going to think about my perfect square. So I know I have 4, 9, 16, 25, 36, 49, 64, 81, and 100. Right? So let's start from the bottom. 100 times another number, does that give me 125? I want a whole number, not a decimal fraction. So that's not going to work for me. What about 81 times something? 81 times 2 is 162, so that's not going to work. 64. 64 times 2 is going to give me 128. Oh, that was close, though. But it doesn't quite work. 49 times 2 is 98. 49 times 3 is 147, so that's not going to work. 36, I don't even like that. What about 25?
Yeah.
25 times what? 25 times 5. So this, I could rewrite to be this. 25 times 5. 25 times 5 is indeed 125. Agree?
Yes, sir.
Now, you can break a radical up or a square root up to be this now. As long as you're under the radical and it's being multiplied, you can create two different radicals. Anyone see a nice thing about square root 25?
Yeah.
What's the square root of 25?
5.
5. So I get 5, and then the square root of 5 comes down. So my answer is 5 square root 5. Thank you. 5 square root 5. 5 square root 5 is an exact answer. Now, students always want to know, when? When am I going to use this? Why do I need this in life? Well, I'm going to give you a perfect example of where this is used Now, whether you choose to understand the math behind it is up to you. Y'all got cell phones, yes? Now, a cell phone needs to go to a cell phone tower in order to figure out its signal. If you're out of range of a cell phone tower, you fall into something called no signal, correct? No service. Error service or no signal or something like that. So, how your cell phone works is this. Now, we have, including teachers and support staff and custodial staff here on this campus right now, probably pretty darn close to 4,000 people. Do you think?
Yeah.
I mean, there's like 3,700 students. We got about 200 teachers. So we got pretty close to 4,000 people within this 80 acres. And if we include campus and we include Bellevue, it could be about coming up on 6,000 people within the 80 acres. Include the CTE building, administration building, the bus depot. It's kind of a lot of people within this 80 acres. Agreed?
Yeah.
I bet you, without having too much knowledge of life, I bet you most of those people have a cell phone. Is that okay to say?
Yeah.
I understand there might be the kid in kindergarten over there at Bellevue that doesn't have it yet. I got you. But I bet you most people do. So if everybody all at once, with all your different types of cell phones, and with all the different types of cell phones that all have different types of carriers, you know, different companies that you use for your cell phone connection, if everyone jumped on their cell phone right now within this region, does this region have enough cell phone oomph?
Yes.
Make sure. It does. But how does it know? I mean, think about it. We just said that within the 80 acres of all of the three schools, the bus depot, the administration building, the CTE building, all Cherry Creek High School, West, our campus in Bellevue, we have a lot of people. So if everyone said, I'm going to get on my cell phone right now, everyone gets a signal because there's some cell phone towers around here, and what your cell phone wants to do is it wants to find a total of 3 cell phones. And it sends a little signal to each of the cell phone towers. And each of the cell phone towers says, back to the cell phone, yeah, I got room for you. But how does it know? Because of an exact answer. Okay? Those cell phone towers, your cell phones, the iterations of your cell phone, in order for it to work, uses an exact answer in order to figure out exactly where it's going to go. Okay? Had it always been that way? No. They're getting better and better with cell phone technology. Okay? Which is pretty amazing. If you ever gone to a Broncos game or a Rockies game or a Avalanche game or a Nuggets game, you just got to go, or just even a concert, go up to Red Rocks, or you go to a concert at any of our venues. Most of society, I got a cell phone out. Can I borrow real quick? Most of society is doing this. Right? Like, we're going to get this deformed crook shape in our arm because we're doing this. I'm going to record this. Now I'm going to watch my screen and record while this is going on. No, watch with your own eyes. You seen this? I know you have.
Hey, but that's my memory.
My favorite are the people who are walking around with the iPads. Oh, look at this. It's a really good picture on this. You want to know where else is a good picture? Your own eyes. You don't have to look at the screen.
That's not how.
Yeah, they're not going to see your phone either way.
What's that?
He's like, what if they're blind? Like,
No,
look at it with your eyes.
No, but I mean, I've seen people. We were up in Yellowstone a couple years ago, and I'm watching this woman. She's walking around the hot springs doing this. Oh, it's such a clear picture. And I'm like,
Eyes are clear.
put the thing down and look at the thing. Don't look at the electronic signal that's coming through. Look with your own eyes.
But what if you can like see like 5 feet and then you
Okay.
look at it with
Then get glasses.
like
So for that one woman I saw, okay, I'll give her that.
yeah.
But the 700 other people that I saw doing it, you can't tell me Yellowstone was the National Blind Convention 2 summers back.
That would be cool.
It might have been, but I didn't see any signs because. So exact answers. This is where this math is used, and that's just giving you one example. Okay, are you happy that you have a cell phone that works?
Yeah.
Heck yeah, you're able to see like the Instagrams and the Facebookgrams and the putograms and the jumpograms and any of the grams out there, right? Some of you have some really cool stuff. I look out at your phone going, that's amazing. Some of you are playing Fortnite on your phone, which is just amazing. It's a cool looking game. I can't say I've played it.
You should try it out.
I know. Everyone tells me I should.
I let my dad play one.
All of a sudden, I start taking all these sick days. Well, where's your story about it? You always playing Fortnite. I don't know. Is it the right thing to do? I don't know. All right, so let's look at another one of these. I have 2 square root of 72. So that 2 outside is going to multiply anything else that comes outside. When I say outside, it means outside of the radical. So let's break 72 down. So again, I know my perfect squares. I have 4 and I have 9. Does everyone know how I'm getting these? 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. And yes, there's infinite more, but we don't have enough time for all that. Okay, so I always like to start at the bottom of the list. It does 100 times another whole number give me 72? Nope. 81 times a whole number give me 72. Now, 64 times a whole number? What about 49? 49 times 2? Oh, that's 98. No, not quite. What about 36? 36 times what gives me 72? So 36 times 2. So 36 is the largest perfect square that works right here. Agree? So 36 times 2 is indeed 72. And I told you before, if you're underneath, you can break up the radical into 2 radicals. And the square root of 36 is what? 6. So I get 2 times the 6, root 2. Well, these are both outside, so they're gonna multiply. 12 root 2. 12 root 2 is the exact same number as 2 square root 72. It's equivalent to it. But again, if you go to your perfect squares, you start breaking them down. Now, the hard thing is, if you start here and work your way down, 4 times something also gives us 72, so you might start there. So I'd say start at the bottom and work your way up. You do that, you're going to get there a lot quicker. Okay? Can I move to the next one? Are you okay that I don't have the actual slides up here?
No.
Some people's learning has just been destroyed. I would have passed the year if you just would have done this one last lecture with the slides I'm actually looking at. All right, I have 2 radicals being multiplied together, and in front of each of those radicals is a whole number. So the nice thing about radicals and whole numbers is outside to outside you can multiply. So that gives me 10, and then inside to inside I can multiply. That gives me 300. Yay or nay? Cool. All right, so let's think about our perfect squares, and if we have to list them every time, we have to list them. So I know 4 times 2 times 2, and then I get 9, I get 16, I get 25, I get 36, 49, 64, 81, 100. Okay, starting at the bottom. 100 times something gives me 300, yes? Yeah, 100 times 3. Sweet. So I get 10, and then I get 100 times 3, because 100 times 3 is 300, yes? Which is going to be the same as this. And the square root of 100 is what? So that's now outside. Well, now it's outside. They're going to multiply. So I get 100 square root 3. 100 square root 3 is the same thing as 5 root 15 times 2 root 20. It's also the same thing as 10 root 300. That's a nice exact answer. The thing is most numbers are going to break down to perfect radicals that we can find. Okay? Are we good? All right. So let's move to the next page. So we have solved linear equations. We've solved this. It's like, yeah, I do this and this, and then I do this and this, and then I do this and this, and I find that I get one whole answer being 9. And if I take that 9 and I plug it back into the original equation, I get 2 times 9, which is 18. 18 minus 6, which is 12. And 12 is equal to 12. That's how the solution works. Agree? Well, then we have this absolute value thing. We touched upon absolute values a long time ago in the beginning of the year, and then we kind of forgot about it, like that uncle that we don't want to talk to, right? How many answers do absolute values have?
1,
2.
What?
They have 2 answers because it's a distance away from some mark. Okay? This one is, hey, we have the absolute values. What numbers are the same distance away from 11? So you could have some number above 11 and you get some numbers below 11 that are the same distance. And you all know that distance is always a positive thing. So I'm going to break this into 2 problems. So I have 2x minus 5 is equal to 11. That looks the same, just without the radicals. And then I have this. And what you do is the side that's less complicated, change the sign. So now I have 2 problems up there to work out. Agree? So let's see. I'm going to add 5. That's 16. I'm going to divide by 2. So I get 8. Okay, there's one solution. Then here, I'm going to add 5. And I'm going to divide by 2. So I have 2 solutions. Now, if it's a solution, that means I should plug it back into the original, and it'll work. So let's plug 8 in. 2 times 8, 16. 16 minus 5, 11. Squared it. The absolute value of 11. 11. Cool. Plug negative 3 in. 2 times negative 3, negative 6. Negative 6 minus 5, negative 11. Absolute value of negative 11, 11. Both answers work. Yeah, baby. Yeah.
So the 2 lines only apply to the answer,
Right. This is just saying there's a distance. And these numbers are the same distance away from 11. Okay? If you plug them in. Cool. So this is the equation that allows these 2 numbers to be that distance away from 11. All right, then you have a quadratic expression, which has 2 answers because it's raised to the 2nd power. It doesn't have 2 answers because it's an absolute value. So if you factor this, you're going to get x minus 4 and x plus 1. And I'm sorry, I went through the factoring quickly, but I think we're pretty good with the factoring. So I know that I can go x minus 4 is equal to 0, and I can go x plus 1 is equal to 0. So that's going to give me 4 here, and that's going to give me negative 1. And again, if I plug those back in, I'm going to get 4 squared, this 16, minus 12, this 4. 4 minus 4 is 0. Giddy up, that worked. Plug negative 1 in, negative 1 squared, 1. Negative 3 times negative 1, positive 3, positive 3. So I get 1 plus 3 is 4. 4 minus 4 is 0. Both answers work. Okay, so there's kind of a lot that's taken place up here. But if you get to this problem, there's a couple of ways that we could think about trying to do this problem. I could maybe bring the 18 over so I get this. And the nice thing is, this is almost the difference of 2 squares. Because x squared is a perfect square, and I have a minus, so there's my difference. But is 24 a perfect square? No, it's 4.9 something, forever. So then you might say, well, this doesn't work as difference of 2 squares, so let's bring the 24 over here. And this just means, hey, I have some number times itself that's going to give me 24. But I don't know how to do that yet. Now, we had brought up last period, someone had said, hey, why don't you divide the exponent on both sides? And I said, well, divide that. That means you're multiplying by half. And then she said, yeah. Okay, so 2 times half, so that means x is equal to 24 to the 1/2 power. So now I have an exponent that's 24. Does anyone have a calculator? You can even use the one on your phone. You know how you turn it sideways, it makes it a little cooler? Yeah. Well, someone try this and tell me what you get. 24, and there's like a caret key of some sort, 1/2. 1/2, same thing as 0.5. So it might be a key that looks like x to the y. So go 24x to the y, 0.5.
Oh my.
Is it a long decimal?
4.898979.
4.8979 keeps going forever, right?
Yeah.
Cool. Okay, now that seems pretty cool. But what happens if I were to do this? What if I take the square root of each side? What's the square root of 24? What's the square root of 24? 4.8979, keep going on and going forever and ever? Yeah, the calculators. Tell me. Jackson? Square root 24. Getting her done. Yeah.
I just have a question. For the previous problem, why can't we just do like the thing of two squares, which is like x plus 2 and then x minus 2
This right here?
for the other one?
This one?
Yeah.
Because that was just a trinomial that factored. It wasn't a perfect square trinomial. It appears like it would be. X minus 2 and x minus 2, but that minus 3x got in the way. Do we get an answer yet? Square root of 24? Anybody? 4, yeah, it keeps going. There you go. Sweet, yeah. And cool, my phone keeps going, so I'm going to keep saying numbers. All right, so this is taking the square root. Now, a big thing that we have to remember here is, remember we talked about absolute value? And you had two answers? This actually will have two answers as well. Okay, and let's build upon that a little bit here in a second. Let's do one that we can see that's going to work. So example 1, I have x squared plus 1 equals 5. Agree? So let's subtract the 5 to get this. Is that a perfect square trinomial? Or is that the difference of two squares? It's the difference of two squares, so that'll break down to x plus 2 and x minus 2, and that'll be equal to 0. So I get x plus 2 equals 0, so that means x is equal to negative 2. And then I have x minus 2 is equal to 0. That gives me 2. So I have two answers that are given. The reason two answers work, if I take negative 2 and plug it in, I get negative 2 squared is positive 4. 4 plus 1 is 5. Yay! Plug 2 in. 2 squared is 4. 4 plus 1 is 5 as well. So there's two answers that work. We have a positive and a negative component. So let's take kind of what we just said, and let's follow the steps to the right over. We have this. It says, get x squared alone. Okay. What did I do there? I subtracted 1 from both sides, yes? And then it says, find the square root of both sides. Root, root. Okay, so I get x is equal to 2. But if I solved it this other way, I got two answers. So once you take the square root of both sides, you get a positive and a negative component to that root. So your answer to this is positive and negative 2. How do I know? Well, I just proved it over here. I have a negative 2 and a positive 2. So if you do a math problem and you're doing the same correct math, just doing it a different way, you have to be able to come to the same answer. So this has two answers for a reason. Okay? So if you take the square root of both sides, if you physically have to insert the square root sign, so if you had this, if you had to take the square root of both sides, you'd get this. But if you were working on a worksheet and it said, hey, what's the square root of 9? The square root of 9 is just 3. Why is that? Well, the original problem was square root 9. What was the original here? X squared equals 9. I had to take the square root of both sides. So that's why if I take the square root of both sides, I have two answers. If I just have a worksheet that says, hey, square root of this, there's only one answer. Example 2. Can I move on? Thank you. Okay, so let's do it our new way. Add 32 to both sides. Agree? Divide both sides by 2. Everyone follow that? So I added 32 to both sides. Here I divided both by 2. But now I'm going to take the square root of both sides. If I take the square root, I have to have a positive and negative component, so I get x is equal to plus or minus 4. There's your two answers. Life good? Let's take a look at this example. 3x squared minus 12 equals 12. Add 12 to both sides. Divide both sides by 3. Take the square root of both sides. Remember, if you take the square root of both sides, you're going to have plus, plus, negative, plus. So I get plus or minus square root of 8. Now, here's the grabber. All right. Let's see. 4 is a perfect square. 9 is a perfect square. 16 is a perfect square. 25 is a perfect square. 36. Ooh, 4 times what? 2. Here's my exact answer. 4 times 2, which is the same thing as plus or minus square root 4 times square root 2. Square root of 4 is? Square root of 4 is 2. So I get 2 square root 2. There's my answer. I have 2 answers. It has a radical with it. That's okay. That's an exact answer. Cell phones work really well for a reason. If you had a real cheap cell phone company who used approximates, guess what? You're losing signal left and right. Why is that? Because 4.61132234445, it's a huge bunch of information trying to go through something. If you have something that's going, oh, it's the square root of 2. It's exact. When am I going to use this in life? Well, shoot, most of you are using your cell phone right now. Last examples. Let's see. 2x squared minus 20 equals 20. Add 20 to both sides. Divide by 2. Take the square root of both sides. Remember to keep a plus or minus. 20 breaks down. Let's see. I got 4, I got 9, I got 16, I got 25. Oh, 4 times something works.
What else 5?
Which is the same thing as this. Which is going to be the same thing as this. Okay? Last one. Can I do it? Hope so. Sure hope so. Boy, if I can't do it, there's something wrong. Uh-oh. Subtract 27, yes? Divide by 3, yes? It's the square root of negative 9. Negative 3. Okay, so that means that negative 3 times negative 3 is negative 9. The answer to this is plus or minus I square root 9. I stands for the imaginary number system, which repeats every 4. So I is equal to the square root of negative 1. I squared is equal to negative 1. I to the third is equal to negative I. I to the fourth is equal to 1. And then it starts over. I to the fifth, I to the sixth, I to the seventh, I to the eighth, 9, 10, 11, 12. You're like, where did this I stuff just come from? Bonus feature stuff. If you just put no real solution on this problem, I'm fine with it. But it is plus or minus. Ooh, it's actually not that. It's actually x is equal to plus or minus 3i because of square root of 9. Oh, so cool. It's just beautiful math. So happy about it. So, hey, you guys want a lot of homework tonight?
Yeah.
Okay, I'll give you a lot. All right, so page 145, 146. 146, and we'll do the evens. So again, I'm not really collecting homework anymore because it kind of becomes a big pain. So if you're that student saying, oh, cool, I just sit here and I get 4 points every day, but you don't actually practice the content, well, you're going to goof the test. I'm just saying. So try and be honest about it. See if you can get something in place and start figuring it out.